This is Mr. Shea for Economics, Chapter 2 at Notre Dame High School. We start out with models. Models are just a economist's way of simplifying the relationship between two variables. It's important to understand that in a model, everything else has to remain unchanged. So if you are doing a model on planes and cars, we just have to assume that everything else remains the same. So there's not a new method of transportation that we're not covering, or that the existing other modes of transportation remain the same. The technology in those transportations remain the same. So we just have to use that model for those two variables, and everything else is constant. When we create a model, there's an assumption. And the assumption is really something that you go into, and so I'll give you an example of an assumption rather than try to explain or just define it. An assumption could be that if oil prices go up, then air travel will be reduced. That's an assumption. And you could draw a model using airplane travel and oil prices. Those are the two variables. Everything else remains constant. Now, if you go through this study and in the end, the evidence confirms this model, then the assumption is accepted as true. However, if you go through the evidence and it does not support your assumption, then the model is thus rejected as not being true. Okay, a direct relationship is a positive relationship between the two variables. That means if one variable increases, then so does the other variable. When one variable decreases, the other variable decreases. They both move in unison. Okay, they'll go in the same way. In an inverse relationship, it's the opposite. If one variable increases, then the other variable will decrease. All right, we went over examples of these in class. You could study and go through a few examples again. Just type in inverse relationship economics, direct relationship economics, and you're going to find plenty of examples of these relationships. Okay, and the title of this is Why Do Economists Disagree? There are two different ways to analyze different economic questions. One of those is positive economics, and this type of economics is probably the most useful, although not the only useful, is based on facts alone. If and then, so you know that everything in positive economics is measurable by facts. If this happens, then that will happen. Okay, if prices rise, then prices rise in corn, then ethanol fuel will become more expensive. That's also a direct relationship, example of a direct relationship, which we were just talking about. It's easily measurable because if corn rises in price, then it is measurable to see if the cost of ethanol goes up. That's positive economics. The other type of economics are normative economics. This is much more of a subjective type of economics because it's not based on facts. And facts can't be used really to prove them false or true. So this is often the type of economics used in stock market analysis. This ought to be a good quarter because, for technology companies, because unemployment has gone down to 6%. It's not something you can really measure. It's not based in factual. It's an economist saying it should happen, it might happen, or that is very good for the economy or very bad for the economy, but it's not measurable or cannot be proven by facts. That's normative economics. Okay, trade-offs and opportunity costs. Trade-off is whatever decision you make, which could be it could be economic based or it could just be life based. Really, it's everything else you give up when you make a decision to do something, and the opportunity cost is the value of that decision. We in class did the opportunity cost of smoking, and we used smoking versus investing your money for a long period of time in the stock market at an 8% rate of return. So for every pack of cigarettes that a person were to buy at $10 a pack of cigarettes, if that $10 were taken instead and invested at 8% over a period of 30 or 40 years, that amount that it would be worth is the opportunity cost between cigarettes, the decision to buy that pack of cigarettes, and or to invest that money. When companies decide or make decisions on changes that they may want to make, they go through marginal analysis. Okay, and that's the decision about how much more or less to do. And when they're doing this, they're trying to decide, okay, what's the marginal benefit? What's the extra gain from an additional unit of change? And the marginal cost. What's the cost associated with this unit of change? Now, the net benefit, which I'll show you in the next slide, is actually the marginal cost subtracted from the marginal benefit. So if these were numbers, and I can't write the numbers here on the screen, I'd like to, but if the marginal benefit were $1 million, but the marginal cost was $1.1 million, then you have a net benefit of negative one. I forget the numbers I just used, but you have a negative net benefit. But if the marginal benefit is $1 million and the marginal cost is $500,000, then your net benefit is $500,000. So in your marginal analysis, you would determine that it makes, as a company, that would actually make a lot of sense to go ahead and do that. Example could be introducing a new product. Apple introducing the iWatch. They certainly did marginal analysis. They looked at the marginal benefit based on studies and surveys, demand, and then they figured out, okay, what does it cost to produce this? And they must have decided in their marginal analysis that there was actually a net benefit to that decision. Okay, production possibility curves. We showed this in class. Unfortunately, I don't have an example on here, but if you want to go ahead and look in your book at the chart again, or if you just type in production possibility curves online, then you'll certainly find an example. Things to remember: the production possibilities curves, again, we're using two variables, two assumptions, and the book uses planes and tanks. I know we joked about one of them being tanks or butter, maybe that's what it was, but anyway, it's measuring the maximum output for these products, these two variables that an economy can produce, given its land, resources, and labor. Remember that in these models, everything else remains unchanged, including technology. To be completely efficient, if we imagine that production possibility curve going just like this again, right? Remember that every point along that curve is efficient. So it doesn't matter if you're producing 10,000 tanks and a million pounds of butter, or 50,000 tanks and 500 pounds of butter. As long as it's on that production possibility curves line, then that is considered efficient. Any point on a graph that is to the left of that curve represents, so if this is the curve again and you had a point here, that means that there's underutilization. It's not an efficient use of the current resources and not reaching maximum production levels. Beyond that, to the right side of the production possibility curve, signals an impossibility. It's not possible based on the current resources available. Okay, this just along that curve again. Remember that the opportunity cost, which you could see and you can graph out, that if you increase the amount of one of the variables, then it is the law of opportunity. Law of increasing opportunity cost means that the opportunity cost for that decision is a reduction in the other variable. So if you use tanks and planes, and you decide you're going to produce more tanks and use the land, resources, and labor to produce more tanks, then the opportunity cost is going to be the production of less planes or fewer planes. Okay, so how does economic growth occur? And if you have this production possibility curve, if we use it just for a large-scale economy, then how can growth occur? Well, it can grow a few different ways, and you could push that line, that curve, further to the right and create a new maximum efficiency point. the acquisition of more land, the acquisition of more resources are easy ways for it to grow. If all of a sudden oil strikes occur, which has happened in our country, when in the early 1900s, when oil was struck in Texas, this rapidly pushed the curve far to the right because of the availability now, mass availability of oil, which took the country off this dependence on whale oil and things like that. The Bessemer process, and technology could also play a large role. The Bessemer process in the late 1800s, when they realized that they could heat steel to extreme temperatures, and so steel became extremely affordable and became the building blocks of our modern day cities, the ability to grow up and expand the population. That is a perfect example of an increase in or a move to the right in the production possibility curve as a result of technological innovation. Okay, that's it for Chapter 2 review. Good luck on the test.